Hello. In this movie, we're gonna continue our discussion of cost of accuracy. So we are going to think about the second case. Now let's assume dependent does not know level of harm. So remember, in the first case that we studied last time, in that case, we assumed dependent knows the actual harm. But now in this case, in this second case, we assume dependent does not know the actual harm. So if something goes wrong and there is an accident, harm can be either small amount or big amount, but dependent does not know whether harm is gonna be small or big. Now we're gonna see that in this case, accuracy has no benefit in our society. So remember, as I explained last time, what was the benefit of accuracy? So benefit of accuracy was to provide incentive to dependent to behave properly. So this was benefit of accuracy. So last time we saw if the court makes accurate decision, then in that case dependent is gonna be more careful when harm is big and less careful when harm is small, and actually that's what society wants. So benefit of accuracy was to provide incentive to dependent to behave properly. So this was the benefit of accuracy. And now we're gonna see that in this second case, so dependent does not know the actual harm. In this case, this kind of incentive does not work because dependent doesn't know whether harm is gonna be small or big. So therefore, in conclusion, we're gonna see that there is no benefit of accuracy. So it's better for the court to make inaccurate decision. So this is what we're gonna see here. So first, suppose the court does not verify. So court does not verify the level of harm. So in this case, the court is going to make inaccurate decision. So harm is either small or big, but court does not know whether harm is small or big. So regardless of the true level of harm, court is going to order dependent to pay $D. So in this case, dependence problem. So dependence problem is dependent wants to minimize expected cost. So this part is carry cost. And if something goes wrong and there is an accident with probability px, dependent has to pay $D regardless of actual harm. So this is dependence problem. So dependent is going to solve this problem. So we know the solution is x star, and this is gonna be a function of D. Okay, so, and again, as you can see here, this is the level of care chosen by dependent, and it's a fixed number in terms of harm. So harm can be small or big, but they don't influence care choice of dependent. So level of care is not changing. So this beneficial incentive effect we saw here does not exist. So in this case, let's think about social cost. So let's think about social cost in this case. So when you calculate social cost, harm is either small or big. So harm is either small or big. So if harm is small, social cost is first care cost, plus and accident cost. So accident occurs with probability. So accident occurs with probability, and accident occurs, there is a harm on plaintiff. So here this HL represents harm. So this blue expression represents social cost when harm is small. First part is care cost and second part is accident cost. If harm is big, then social cost is first care cost plus if there is accident, there is accident cost HH. So again, this is level of harm on plaintiff or loss of plaintiff because of accident. So green expression is social cost when harm is big. So we know that harm is small with probability 50% and harm is big with probability 50%. So we can calculate expected social cost by multiplying half here and add them up. So this entire expression is expected social cost when court does not verify level of harm. So in other words, social cost when court makes inaccurate decision. We can further simplify this expression. So if we simplify this expression, we get this expression, and as I explained before, this expression can be written as this. And remember, the meaning of this expression is this expression means expectation or average of harm. So we found, so this purple expression is expected social cost when court makes inaccurate decision. So social cost. So social cost under no verification is This is social cost under no verification. And suppose suppose court wants to minimize this social cost expression. So suppose court wants to minimize social cost. So in other words, we want to think about minimization problem. So if we want to minimize the social cost expression, what must be level of D? So remember, this D is chosen by the court. So because court does not know whether harm is small or big, regardless of actual harm, court is going to order defendant to pay D dollars. So here our question is, what's gonna be the best choice of D if court wants to minimize social cost expression? And actually last time we thought about this problem. So last time we thought about this problem. So remember, if we solve this problem, solution is this. So if you put this solution back to our original function, then we get minimized function value. So we get minimized function value. So this blue expression is the minimized function value of our original function. And as you can see, when this function is minimized, this number appears everywhere. Therefore, if we want to minimize this purple expression, this number must appear everywhere. So that means D must be average harm. So actually this is what we saw last time. So intuitively it says when the court does not have information, so the court is not sure whether harm is small or big. So in this kind of situation, the court is going to order defendant to pay average harm. So using this expression, we can write down social cost under no verification as so this is our social cost. So this is our social cost under no verification. So as we did last time, so we found this blue expression, social cost under no verification. And now we're gonna calculate social cost under verification process, and we are going to compare those two social costs. So now let's think about what's gonna happen if the court verifies the level of harm. So in this case, court is going to make accurate decision. because of verification process, now the court knows, exactly know whether harm is small or big. Therefore, the court is going to order defendant to pay actual harm. So this means defendant has to pay HL if actual harm is HL, and defendant has to pay HH if actual harm is HH. So in this case, let's think about defendant's problem. So defendant wants to minimize his expected cost. Defendant's cost is first care cost. And if something goes wrong and there is an accident, defendant has to pay a certain amount of money. So what is this expression? First, we know that court is going to verify the level of harm. So in this process, defendant has to pay cost K plus defendant has to pay damage equal to harm. So this means damage is going to be HL or HH. But remember, here dependent is not sure whether harm is small or big. So dependent does not have information. So dependent does not know whether he has to pay small amount or big amount at the court. Dependent only knows that he has to pay small amount of money with 50% and a lot of money with 50%. So in other words, here, this damage expression is gonna be average harm. So average harm is going to appear here. So this is dependence problem, and please make sure to compare. So to compare this problem, let's say this is so make sure you compare this expression, let's say this expression. So this expression and the corresponding dependence problem when dependent has information about actual harm. So this is dependence problem when dependent has no information. So dependent has no information. It means dependent is not sure whether harm is big or small. And last time, remember, we thought about dependence problem when dependent has information. So in that case, we thought about dependence cost minimization problem when dependent knows whether harm is small or big. So in that case, we know that this part is changing. So this part is either HL or HH, and it is changing depending on the actual harm. But as we can see here, it's not changing anymore. It is just a fixed number. So therefore, if we solve this problem, we get solution So this is our solution on it, and as you can see here, this expression is not changing depending on level of harm. So if level of harm is HL, actually level of harm is small. Solution is this. and actually level of harm is big, solution is still the same. So in other words, our desirable incentive effect is not working here. So eventually, as I told you, eventually we're gonna see that there is no benefit from accuracy. So now let's calculate social cost. So we want to calculate social cost under verification. Harm is either small or big. So if harm is small, what is social cost? First, care cost. So this part is care cost and plus accident cost. So if something goes wrong and there is an accident, so we know that accident occurs with this probability. And if there is accident, there is a harm on plaintiff, so HL. So HL. And second, there is a verification cost. This is also captured as social cost, so K appears here. So this blue expression is social cost when harm is small. And if harm is big, social cost is first care cost. So care cost plus accident occurs with this probability. So accident occurs with this probability. And if there is accident, there is a harm on plaintiff, so HH. So HH is actual harm. And plus verification cost is also captured as social cost. So this green expression is social cost when harm is big. So harm is small with 50% probability and harm is big with 50% probability. So we multiply half. So we multiply half to both expression and add them up. Then this entire expression is social cost under verification. And we can simplify this expression. So if we simplify this expression, so if we simplify this expression, in the end we get average harm here plus K. So this purple expression is our social cost under verification. So in other words, when court makes accurate decision following verification process, then our social cost is this purple expression. And if the court makes inaccurate decision by making if court makes inaccurate decision and it does not verify actual level of harm, then our social cost is this blue expression. So now we want to compare these two. So we are going to compare these two expressions. So social cost under no verification. So social cost under no verification is this expression. This is social cost under no verification. And then social cost under verification is, it looks similar. So this is social cost under verification. If you look at these two expressions, they look similar. And the only difference is here. So we can see that in general, if you write down social cost expression as this, so if you write down social cost expression as this blue expression, we can see that this number A is bigger for social cost under verification. So if this K is a positive number, so this is verification process. So we can imagine K is a positive number. Then we can see that social cost under verification, this number A is bigger. So this number A is EH plus K for social cost under verification. And this number A is just EH for social cost under no verification. So as long as K is a positive number, we can see that this number A is bigger for social cost under verification. So now our question is, in this blue expression, if A gets bigger, what's going to happen to this blue expression? So if this blue expression is increasing in A, so in other words, in this blue expression, if A gets bigger, this blue expression also gets bigger. What does it mean? It means social cost under verification is bigger than social cost under no verification. Because if you compare these terms, we can see that for social cost under verification, this number is bigger because of positive K. So now our final step is to verify. In this blue expression, if A gets bigger, what's going to happen to this blue expression? So we're going to see that this blue expression is increasing when A is increasing. So how do I know? We can see that let's call this expression as a large f function, and let's think about variable as A. And actually this is what we saw last time. So let's call this blue expression as a big F function, and let's consider this big F function has a variable A. Then our question is, what is the value of this first derivative? Is it positive or negative? So this is our question. So if this is positive, it means this function f is increasing when A gets bigger. So in other words, this blue expression is increasing when A gets bigger. So this is what we are going to show here. So let's take derivative. Then first, So let's take derivative plus, and we thought about this problem last time. So if you look at this second term, if you look at this purple expression, we can imagine it is a product of two things. So remember, we are going to use this differentiation rule. So if you take derivative of this expression, the rule says derivative of first term multiplied by second, and first term multiplied by derivative of second term. So we are going to do this. So derivative of first term multiplied by second term plus first term multiplied by derivative of second term, so it is just 1. And what is this expression? So again, we are going to use another differentiation rule. So inside the function, we have a function. So in this case, we take derivative, then what we get is, so derivative of outside the function multiplied by derivative of inside the function. So this is a rule. So this blue expression here, this becomes derivative of outside the function multiplied by derivative of inside the function and multiply a. So plus. So now we have common term x star prime a. Plus. So this is what we get, and we know that this green expression is equal to 0 because from our usual problem, so remember, if we solve this problem, we have to take derivative. So we have to take derivative and set it equal to 0. Then we get solution x star a. So this means when you put this solution back to this equation, we still have this equation 1 plus p prime xa equals to 0. So because of this part, this green expression must be equal to 0. So this purple expression is gone. So purple expression is gone. So in the end, we just have this blue expression. So we just have this expression. And as you can see, this is a probability. So this is positive. So in other words, our f function, so what was our f function? So our f function was so this is our f function, and first derivative is positive, so it means if this number a gets bigger, this expression gets bigger. Therefore, as I told you here, if you compare green and purple in these two expressions, purple is bigger. Therefore, social cost under verification is bigger than social cost under no verification. So our conclusion is social cost under verification is bigger than social cost under no verification. So this means no verification is better for our society. So in other words, no verification means inaccurate decision. So maybe the courts are making inaccurate decision. So here inaccurate decision means actual harm is small. So actual harm is small, but still the court orders defendant to pay average harm. So in this case, average harm is bigger than HL. So in this case, the court's decision is inaccurate, and defendant is paying more than the harm he inflicted on plaintiff. And if harm is big, in this case, defendant still pays average harm. So in this case, defendant is paid less than actual harm. So again, decision is inaccurate. So our courts are making inaccurate decisions, but still we shouldn't try to fix this problem, because if we try to improve accuracy, there is a cost. So that's bad. And there is no benefit from higher accuracy. Because again, as I told you before, what is the benefit? Benefit was incentive effect. So in this case, our benefit is incentive effect. And in this case, incentive effect is not working because defendant is not sure about actual harm. So in the lecture before, in the first part of lecture in this section, we saw that if defendant knows actual harm, there is desirable incentive effect. So defendant is trying to be more careful when actual harm is big and less careful when actual harm is small, and this is beneficial for our society. So in general, in reality, there can be many other kinds of benefit from higher accuracy, but here, as an economist, we try to think about this incentive effect as our benefit from higher accuracy. So our conclusion is, if there is no such desirable incentive effect, then there is no benefit from higher accuracy. So we shouldn't try to improve accuracy in our court. So up to here, we thought about if there is a cost in improving accuracy in our court, should we try to improve accuracy? So the conclusion is, if there is desirable incentive effect, which is our benefit, and then we should try to improve accuracy, but otherwise we shouldn't do that.